Hey YouTube, thanks for visiting. Hope all you are doing well. So, in this video, we are going to learn what is the rank of a matrix. So, this is the most important and demanding topic of linear algebra. And in this video, we are going to discuss uh, different types of definitions of rank definitions. So, there are more than one definitions or way that you can define actually the rank of a matrix. This is very important. And how to find the rank? So first is what is rank, second one is how to find the rank, and third one is some properties of rank. What are the properties of rank? So this video is a very basic video, but I will give you very the concept or the definitions of rank. There are more than one way, 5 to 6, 7, 8, 9, 10 ways that actually how you can define the rank. So let's start. And before starting, I am requesting you to all those who are new in my channel, please go like this video, share with your friends, and subscribe the channel. Okay. So what is rank? Rank of a matrix. So first, very basically, we can say that number of maximum number of linearly independent rows or columns of matrix is called the rank of a matrix. So from this is the tagline: row rank equal to column rank equal to rank of the matrix. I'll come the example just before the just after the definitions. One by one we will discuss all the definitions, fine, and justify to show that how to justify the definition to of the rank of a matrix. Number two is dimension of row space and column space. So for those who are beginners, I think they don't understand what is row space and what is column space and what is their dimension. So those are very beginners, you can skip this thing. And those who are already know that what are row space and what are column space, then they all know that the dimension of the subspace spanned by its rows, that is the row space, or columns, that is the column space, is called the rank of a matrix. Fine. Now, third number that we can define the rank of a matrix. What is the third definition? The rank is the order of largest square submatrix or minors with non-zero determinant. This is the definition. Next, number four. Number four is a number R is called the rank of a matrix. Order of the matrix is m by n if every submatrix of order R plus 1 or more is singular. Singular means the determinant is 0. Singular means determinant of the matrix, suppose this is 0. Okay. And number two, there exists at least one square submatrix of order R which is non-singular. So this is definition. Now what are the definitions? We come one by one. Thus, the rank of a matrix is the order of highest order non-singular submatrix and is denoted by row A. So this is one like notation. Many of the books also denoted by this rank of A or rank of A like that. So these are many notations there are for rank of a matrix. Number 5 definition is row reduced echelon form. The number of non-zero rows in no row reduced echelon form or the pivot positions of a matrix is also called rank of a matrix. So there are 5 definitions that in this video we will provide, but there are more than 5 definitions of rank. So now just discuss the definitions one by one by taking the example or from here that how can you find the rank of a matrix. See here, this matrix, suppose A is a matrix and this is a 3 by 3 matrix, and 3 by 3 matrix means this is a square matrix. Okay, so this is a square matrix. So the definition that we didn't discuss in the definition, what are that? So for a square matrix, first if you want to or if you need to find the rank of a matrix, then what is you do first? For a square matrix, we first find the determinant of A. If determinant is equal to non-zero, then we say that definitely the rank is 3. But if the determinant is non-zero or determinant is suppose 0, then the actual complexity comes in the ground. Okay, but without find the determinant, we also can find the determinant. So this is helpful if the determinant is non-zero. Otherwise, this is not helpful basically. So that's why I didn't include in the definition. Okay. So see, what is the first definition? The first definition is what is the number of linearly independent rows and or columns. Fine. So see in the definitions. So first row is 2 1 0 2 1 0. Second row is 0 2 3. So this is the two row and third row is 0 0 0. So this 0 0 0 is obviously linearly dependent of these two, because we can write 0 0 0 as is equal to 0 into 2 1 0 plus 0 into 0 2 3. So this is the linear combination basically. So we don't need to check this. So this 2 1 0 and 0 2 3, obviously you can say that these two are linearly independent. Just by observing you can say that, because these one or two rows, these two rows cannot be right like 2 1 0. This is suppose alpha into 0 2 3. You cannot write this. Okay, so that means these two rows are linearly independent. That means what is the rank? Rank of A equal to 2. So this is the first definition from the first definition that I told you. Fine. So now what is the second definition? Second definition is dimension of row space or column space. See here, if we see also the row space, fine. Row space means actually non-zero. Skip this. See these two actually, the rows actually span this matrix A of the that's from that point of view we can say that the rank of this matrix A is 2. Okay. So this is the case, or column in that column case, this is also you can say. Next, the third number is the rank of the order of largest square submatrix or minors. See, here we can get a square submatrix like 2 1 0 2. So this is a 2 by 2 submatrix. 2 is a 1 order submatrix. This is a 2 by 2 order submatrix. Okay. So one, this element is non-zero, but and one if you take any one single element 1 by 1 matrix, then they are maybe 0, they are maybe non-zero. So don't it actually क्या बोलूं मैं, इसका कोई मायने नहीं रखता है कि वन ऑर्डर के एलिमेंट का फाइंड करना में. ठीक है. नाउ इफ वी सी that this two order sub matrix, then we can say that a determinant of this matrix is non-zero because date of this matrix is what? 2 into 2 4, 2 into 2 4 and 1 into 0, that means 4. That means we get a submatrix of order 2 which is non-zero. That means rank of A equal to 2. We can say that. If we take another submatrix, this suppose 1 0 2 3. So in this case also rank is 2, that this is non-zero. The determinant if we take, this is non-zero. So rank of A equal to 2. So this is the third definition that also justified this definition. Now fourth definition, it is similar kind of with respect to 2. If a number R is called rank of a matrix M by N, matrix if every submatrix of order R plus 1 or more is singular. So see here, if we take the matrix of order 3 here, that is A, and determinant of this 3 by 3 matrix is 0, that is R equal to, if we take 2, then for every R plus 1 element is 0, means every R plus 1 submatrix or minor, okay, is 0. So that means, and there exists at least one square submatrix of order R which is non-singular, and for non-singular submatrix, if we take this submatrix or if we take this submatrix, then these two are non-singular. So that means this matrix is of rank 2. So this is the another definition. Okay. Now in row reduced echelon form, in row reduced echelon form RREF, the number of non-zero rows or pivot positions in a matrix is also called the rank. But how it is valid? See, this matrix we can say this is in row reduced echelon form, row reduced form, because we know that if row reduced form, if there is one element non-zero element, then rest elements in between in the below are 0. So these two are here non-zero elements, below elements are 0, and this is non-zero zero element, but this rows is treated as a actually pivot, and this row is also treated as a pivot. So if you see the definition of this row reduced echelon form, then you can definitely say that these two are pivot and this is not a pivot. So number of pivots or pivot position is 2 here, and these two actually rows generate the row space of the matrix. So or spanned, this space is actually spanned by these two non-zero rows. So that from this definition you can say that rank of this matrix is equal to 2. So there are 5 definitions that we can validate that rank of A equal to 2. Then the next example, this is a 3 by 4 matrix, which is a rectangular matrix and which is not a square matrix. So the determinant concept is not valid here. So you can either go through that submatrix concept, submatrix, or you can go with the linearly dependency or independency, Li or Ld. So if we see this matrix, okay, so this first row and third row, what is R1 and R3? So see carefully, we can write this, I think, R3 equal to minus 6 into R1. That means these two rows are linearly dependent, and these R1 and R3, R2 are linearly independent. Okay, that means we get R1 and R2 are linearly independent. That is, we get two linearly independent rows here. And if we get two linearly independent rows here, then we can also say that rank of this matrix A equal to again 2. So from this concept, you can also say that this is again a rank 2 matrix. Also, by the minor concept, so this, if we check this minor 1, 2, 2, 3, 9. So this is equal to what? 3 minus 4 equal to minus 1, which is non-zero. So we can say that rank of equal to, we get at least one minor, which is order to is rank of A equal to 2. Now if we check, because this is a 4 by 3 by 4 matrix, so we also have to check that whether this 3 by 3 submatrix is 0 or not. So we can check also that 3 by 3 submatrix, which is 1, 2, 3, 2, 3, 1, minus 6, minus 12, minus 18. So this is a 3 by 3 submatrix of the whole matrix. So see, if we see that these two rows are actually linearly dependent, R1 and R3, that means if we take the determinant, suppose this is a B submatrix, okay, this is a B matrix, which is a submatrix, this is a B matrix, which is a submatrix of A. So from the definition, I think 4, from the definition, yes, 4, this 4 definition, what we say that this B equal to rank, determinant of B equal to what? Determinant of B equal to 0. That means we need to get an non-zero submatrix. Fine. We need to get an non-zero submatrix, but this here we get the zero submatrix, or rank of determinant is 0, or that means this B is singular. Therefore, rank of this A is not 3. That means rank of A is equal to again 2. Also, if we see some properties of this rank, then we will just come, we say that the rank of A is less equal to minimum of number of rows and number of columns. Number of rows is 3, number of 4 is 4. That means minimum of 3. That means rank of A, this matrix rank of A is less equal to 3. That means it may be 3, may less than 3. So we check already that we get rank 2. That means rank is 2, less than 3, 2 is less than 3, that is, this is validated again. So see how this concept actually means related to each other, that 5 definition that I shared with you guys. Okay, so now some properties of rank. So these properties are very important. If we read the rank of a matrix, first is for a matrix A is the number of rows and M is number of rows and N is number of columns. Fine. So that I say that just earlier, the rank of A is less equal to minimum of mn. Fine. Then if rank of A equal to 0, if and only if condition, determinant of A is equal to 0. It is obviously for square matrix. Square matrix, because otherwise why square matrix we cannot find actually the uh, sorry, no, this is zero matrix. If that is A equal to suppose 0 0 0 0 0 0, this is zero matrix completely. So 0 2 by 3, so rank of A equal to 0. So and conversely, okay, so this is the property number 2, not for square matrix. This is not fine. If A not equal to 0, this is 0 matrix. 0 means 0 mn. Okay, 0 mn. Then rank of A obviously greater than 1. So see, if we see just 2 and 0, this is also a matrix. 2, this is a 2 by 1 matrix. And see, this element 0, but if we take this as a matrix, then this matrix is non-zero. That means, and again, what is that? The rank of the matrix is, if we see the row, there are two row and one is non-zero row. That means rank of A equal to 1 here in this case. And also this property number 1 is also validate that rank of 2 is, rank of this matrix is minimum of 2 and 1, that is again 1 here. Fine. And if we see column wise, then 2 0 is a non-zero column, 1 single column, that is rank is 1. So see how beautiful that property is also. Fine. Number 4 says that if A is a n by n non-singular matrix, then rank of A equal to n. So if we see that 1, 2, 3, if we take just any matrix which determinant is non-zero, determinant non-zero means matrix has full rank, that is n. Here it says that n by n, that is square matrix. Okay, this concept actually, this determinant concept or non-singularity concept is valid only for the square matrix. Fine, not for the others. Similarly, for 5, if A is in n by n singular matrix, then rank of A equal to n. That is also valid. This is also true actually. These actually statements have proof, but we don't need proof for solving the questions. We just go through these properties. Number 6 is that if B is a R by R square submatrix of A such that rank of B equal to non-zero, then what rank of B is greater equal to R? What is that? Suppose we have a 3 by 3 matrix here, 3 by 3 matrix here, and 2 by 2 submatrix here, such that this 2 by 2 submatrix is non-zero. So that doesn't mean, if 2 is 2 by 2 submatrix is non-zero, that doesn't mean that rank of is obviously 2. This is greater equal to 2. We have to, suppose this is 4 by 4 matrix. So we have 1 by 1 submatrix, 1 order submatrix, we have 2 by 2 order submatrix, we have 3 by 3 order submatrix, we have 4 by 4 order submatrix. So you already also check, that is, if this is non-zero does not means that rank is 1. Rank is more than 1. If this non-zero, then doesn't mean rank is 2. Rank may be 2 or greater than 2. Similarly, for this, if this is non-zero, then rank is 3 or 4. Fine. So this is the property. And we can say that if this we get this submatrix 0, then we say that rank is 2. Fine. So that what is the case is that if you get 2 by 2 is non-zero, then you have to check one higher order submatrix. If you get that is 0, then you say that the rank is in back 2, like that. Okay. Then number 7, rank of a matrix doesn't change if it is subject to elementary row operation or column operation. Suppose this is a matrix row 1, row 2, row 3. If we interchange this R1 and R3 suppose, then rank or C2, C3, if we interchange this two row or column, then rank is not affected actually. Next, number 8 says that if rank of A is a number of non-zero rows or in the row reduced echelon matrix. So we discussed it earlier. Now, number 3 is most important, and from this result actually questions makes in the exam, which is that uh, rank of A plus rank of B minus n less equal to rank of AB less equal to minimum of rank of A and rank of B, and AB is the product. Fine. Now, what is n? Okay. Suppose A is the matrix m by n and B is the matrix n by p. So this is the n. Okay. So if we multiply AB, then AB, order of the AB is m by p, right? And this is the n actually. This n is that rows in number of columns of A and number of rows of B. This is the n. So rank of A minus rank of B minus n. This is less equal to rank of AB. If we multiply AB, this is minimum of rank of A, rank of B. This valid in all actually matrix A and B for rectangular matrix. For square matrix also, if we take A 3 by 3 and B is also 3 by 3, then the AB rank is obviously AB, or order of AB is 3 by 3, then n value is 3. And if we take A is 4 suppose by 3 and B is 3 by 5, then what is the order of AB? Order of AB is 4 by 5, and in that case the value of n is equal to 3. Fine. So this is n. Now number 10 result is, if a matrix multiplied by a non-singular matrix, then rank of it, the original matrix, does not alter. So suppose A is a matrix, rank of A equal to 5, and A is a, suppose A is a 5 by 5 matrix. Fine. Now if we take B is a matrix such that B is a 5 by 5 matrix such that date of B is not equal to 0, then if we multiply like AB or BA, then if we multiply the matrix A by B or like that, then the rank of the original matrix does not change. Fine. So these are the 10 properties, most important properties related to rank. And so we define in this video what is rank, how can we calculate the rank, in 5 ways I here discuss, and some properties. I think these properties, okay. So this is very important topic for linear algebra for any exams of mathematics. These are very basics related to rank. So how was the video? I think this video is very helpful. So if this video is helpful for you, then please give a like to this video, share it with your friends. Don't forget to subscribe the channel and leave a comment if this video is helpful again. Okay, thank you.